Welcome grade 12s to Pedagogical Science Institute, where we do what we do for the people. This is the second video in our geography Matric revision series. Remember that in the previous session we were looking at the topic mid-latitude cyclones, while in this session we are looking at the topic tropical cyclones. Now, remember some of the things that we looked at in the previous session. Now, we looked at what is some of the important content that you need to understand before you go into your examination with regards to the topic mid-latitude cyclones. Now, in this session, we'll be looking at what are some of the important concepts that you should be understanding before you go for your tropical cyclones examination. In your geography paper 1, remember it falls part of that in the climate and weather section of geography. Now, the first thing, as per your guideline, your examination guideline, remember this is the latest examination guideline issued by the Department of Education, the Department of Basic Education rather. Now, it says here we must first understand our general characteristics. Now, what do we look at when we look at general characteristics? Now, general characteristics simply looks at what are the defining features unique to the system of study. What unique features do we look at when we are looking at the particular system? Now, we are studying tropical cyclones. I think the first starting point will be to look at what does the name itself tell us about the system. Now, it says tropical cyclones. Now, remember we looked at what cyclones are. If you go to the video from session number 1, we differentiated between high pressure systems and low pressure systems, and we looked at the differences between the two. Now, since we are looking at cyclones, remember we defined them as low pressure system. So a cyclone is a low pressure system. It means that all tropical cyclones are low pressure systems. That's one of the general characteristics associated with this system. And again, we think about where do they form? Where do they form? Now, what tells us where they form, and I think it covers the second point there, area of formation. What tells us where they form is the name itself. We call them tropical cyclones. Means that these are cyclones or low pressure systems that occur in the tropical regions. So let's remember that point. They occur or they form in the tropical regions. And where are our tropical regions? It's between 0 and 30 degrees, but we are always specific to say tropical cyclones form between 5 and 30 degrees, both north and south. And again, since they are cyclones, it means that they are associated with an intense low pressure, which means the pressure in this system is below 1000 hectopascals. It must always be below 1000 hectopascal. So let's remember that point. Now, when do they occur? At what time of the year do they occur? We know that they occur late summer, early autumn. Why late summer? It's because of a very important point. We need for them to form in warm oceans. And what better time will these systems form than in the summer season? And then late summer, it's really hot along those around that time of the year. So that's when our systems are going to form, late summer. And again, since they are cyclones, another general characteristics of this system will be in the circulation. We know that all cyclones, all low pressure systems in the southern hemisphere circulate in a clockwise direction. and all low pressure systems in the northern hemisphere circulate in an anti-clockwise direction. Very important point for you to know. So you need to know how to identify in which hemisphere are these systems in based on their circulation. And again, we talk about the general movement of these systems. We say that they move from east to west. Why do they move from east to west? It's because they are formed in our tropical regions. Remember that. And in the tropical region between 0 and 30 degrees, we have tropical easterlies as the winds dominating that region. And since we have tropical easterlies dominating that region, it means that these systems will be steered. They will be steered, or they will be driven, or they will be protruded, or caused to move in the westerly direction as driven by your tropical easterlies. Since they are in the easterly wind belt, they are going to be forced or made to move in the westerly direction, or from the east to the west. So very important point. That's one of the general characteristics of these systems. Now again, they are associated with a very steep pressure gradient. They are associated with a very steep pressure gradient. And why are they associated with a very steep pressure gradient? It's because they are low pressure systems. And in a low pressure system, we will always have air entering the system. Now, if we look at our satellite image that is shown on the screen here, it shows us exactly what I mean by this. We know that with all tropical cyclones, with all low pressure systems rather, we have air moving towards the center of the system. And what rule in geography assists us in explaining that? We call that the pressure gradient force, which simply states that air will always move from a region of high pressure to a region of low pressure. So that's pressure gradient force. And because of this, we say these systems have a steep pressure gradient force simply because we have air entering the system, as you can see, as I'm showing you with my laser, and as you can see in the animation that is here, we have air entering the system. Now, if you were asked in which hemisphere is this system at, remember we look at the arrangement of the clouds. They tell us which hemisphere is it in. Now, if you look at it, it is circulating in an anti-clockwise direction. And as a result of this, we say this tropical cyclone is in the northern hemisphere. And remember that in the northern hemisphere, they call tropical cyclones hurricanes in some of the regions. So we'll look at a map just reminding you what we call them in the different regions. But that's one of the characteristics. Now another one to think about is that, now remember that our air is entering the system. Now at the center of the system, we have the development of what we call an eye. One of the general characteristics of these systems is that they are associated with an eye in the center of the low pressure. And then again, on the sides of the system, you see that we have clouds, intense, thick clouds. And since they are associated with these thick clouds, we automatically know that they are going to be associated with very stormy weather conditions, severe winds or strong winds. And why is that? Remember that these thick clouds are cumulonimbus clouds, and cumulonimbus clouds, remember, are just a mixture of cumulus and nimbus clouds. And cumulus clouds are our fluffy clouds that are rich in rainfall, and nimbus simply means the action of water falling on the earth. So cumulonimbus clouds are just our thick, intense clouds that are associated with heavy rainfall. So that's why cumulonimbus clouds are associated with severe rainfall. And when we have this severe rainfall, we have winds that run up to 300 kilometers per hour, very strong winds as a result of that, because of the cumulonimbus clouds surrounding the eye wall. Now, so we say that these systems, because of these clouds, remember, are associated with heavy rainfall, hail, storm surges, hurricane winds that are so strong, that are lead to the damage to infrastructure. And that's why we say we need to take precautions when these systems affect us. So those are some of the general characteristics of tropical cyclones. And another one is that we give these tropical cyclones names. Remember, we name them alphabetically from the first letter to the last letter. So remember, we name them in the order of occurrence or occurrence, which tells us that which one affected the region first, because you'll find that within one summer season, 1 year, we'll have a series of tropical cyclones. So we need to keep record of which one occurred when, how strong was it, what impact did it have, so that we are better ready for the system if it affects us in the future. So we also think about that. And we say that they usually affect, another general characteristic, they usually affect the east coast of continents. Why? It's because they move from east to west, means that they are steered by our tropical easterlies towards the westerly direction, and they will be affecting our west coast of our regions. Remember, with mid-latitude cyclones, we said that they affect the west coast because they move from west to east. So remember those points. Those are the differences between the two. You must never mix your mid-latitude cyclones with your tropical cyclones. Very important point to note. Okay, now what else again can we think about? We know that these cyclones, again, as a general characteristic, they develop over the ocean. And we know that when they get on land, they die out. That's another general characteristic that is unique to these systems. Because with a mid-latitude cyclone, it can form over land, it can form over the oceans in your 30 to 60 degrees line of latitude, or in your subtropical westerly wind belt. That's where they form, and they get to land and they can stay longer on land and survive. So they are not really affected by friction and that they stay longer on land. So we don't really talk about them dying out due to friction on land. While with tropical cyclones, they need an ocean surface for them to survive in the long term. And we say they usually die out on land because of friction and lack of moisture. So they need to always have a constant supply of moisture for them to survive the longest time. So that's a very important point to think about again. So these are some of the general characteristics associated with our tropical cyclones. Now, the next point says we need to also know the factors necessary for their formation. So what ingredients are necessary for tropical cyclones to form? Now, I like to describe it this way. Now, think of your tropical cyclone, think of your mid-latitude cyclone, and think of your other systems that we study in geography as a recipe of some sort. Now, when you are cooking a stew, for example, a beef stew to be specific, you know that you need specific ingredients for this stew to be yummy and nice, right? For it to be cooked and prepared to the best way possible. So you need to meet certain condition. You need to have certain ingredients for the stew to be nice and yummy and juicy. Now think about tropical cyclones in that way. For example, when you are cooking your stew, we know that you need to have remember we said it's the beef stew, so you need to have, number one, your beef. So without the beef, we can't have the stew, the beef stew rather, because it's a beef stew because of the beef. So we need to have the beef as one of the ingredients. We also need to have water, right? So that it doesn't burn, and it allows for the beef to be cooked through thoroughly, so it facilitates the transfer of heat between the surface of the pot and the different parts of the pot. And again, we also need to have your vegetables. You need to have your salt, your beef stock. You need to have your different spices. If you're making a beef stew biryani, you need to have your biryani spice, for example. So these are some of the conditions necessary for this stew to be cooked. And again, you need a heat source, right? You need a stove to provide heat for this stew to be cooked. And you also need a pot. Remember, you cook it in a pot. Now, how is this assisting us in understanding general characteristics and our factors then necessary for the formation of your tropical cyclone? Now remember, for a tropical cyclone to form, we always say that we need to meet certain conditions. Number one, we say that the tropical cyclone is supposed to form between 5 and 30 degrees from the equator. So they form 5 degrees outside the equator to 30 degrees. And why do they form between those two regions? It's because we have the presence of the Coriolis force. So this Coriolis force is the force that causes the wind to be deflected, leading to the formation of our vortexes. Remember, a tropical cyclone has the first and the second vortex. So for the vortexes to form, we need to have the horizontal movement of wind. And remember that how this wind moves is dependent on in which hemisphere is this system in. Because Farrell's law is specific to say if it's in the southern or the northern hemisphere, winds are either deflected to the right or to the left. So for the vortexes to form, we need to have the horizontal movement of wind, the deflection of wind. And since we are looking at then a tropical cyclone forming, we need to have the deflection of this warm ocean wind being deflected in order for it to form our two vortexes. And we'll look at how does that happen. And we say that we need the presence of the ocean. Why the ocean? The ocean is frictionless. Are we fine with that? The ocean is frictionless. Same applies to when you are cooking a stew. You can't use the pan for frying eggs, right? Because a stew is a mass kind of a meal that needs to be enclosed in a bigger pot, and so that it can cook through properly. So you can't use the frying pan for that. Are we fine with that? So for tropical cyclones to form, they need to form in the ocean surface. So in this case, it's our ocean surface is more like our pot, because it carries this system and ensures that it lasts in a durable manner, it lasts longer. So that's what we need. And we say that the ocean surface must be above 26.5 or 27 degrees Celsius. That's a very important one. Since they form the ocean, we need to have temperatures above 27 degrees Celsius. And why must we have those temperatures? Remember, when temperatures are above 27 degrees Celsius, it means that we can have our evaporation of air. And what happens to this evaporated air? This air converges. Why does the air converge? Remember, in a low pressure system, air always converges. Converging means the air is coming together to some point, comes together, converging. That's what we mean. And we say warm air always converges. Now, when the air has converged, it reaches a certain point and it does what? It rises. Remember that warm air always rises while cold air always sinks. So what's going to happen is that you're going to have your rapid evaporation of air in the ocean surface as a result of high temperatures, and we are going to have air converging in that system. And what is it gonna do? It's going to rise, right? And after it has risen, remember, as it goes up, it's going to cool down, because the higher you go, the colder it becomes. And when it reaches the top, as this air is now cold, remember, it hasn't lost its moisture, it's just cold, because the higher you go, the colder it becomes. So this air is going to condense, form clouds, this intense cumulonimbus clouds, and as a result, we are going to have the two vortexes forming. And at the top of the atmosphere, we know that we have cold air. Are we fine with that? And since we have cold air, this cold air always sinks. So what is it going to do? It is going to enter the system or sink towards the center of the system, and that is where the eye is formed. And as it sinks, it warms up adiabatically, and that's why in the eye takes us to this section. That's why we say then in the eye, the associated weather conditions with the eye is that we don't have cloud cover, we don't have winds. The wind or the air that is there is warm. Why is it warm? It's because of adiabatic heating. We're fine with that. And we say that we have stable weather conditions because there's no precipitation taking place over there. So these are some of the conditions necessary for the formation of a tropical cyclone. We don't have to have friction. We don't want to have friction. We need to have strong surface convergence of air and convection of air as it goes up. And we say when it reaches the atmosphere, it diverges, forming our two vortexes. At the center of the system, we'll have the eye, and in the eye, our air is going to enter the center of the system, and it's going to warm up adiabatically, which means by the time it reaches the surface, it is going to be very warm. So we'll look at some questions to try and explain this further and see how do you apply this when you are given questions. And you'll also have to know the cross sections for tropical cyclone. Just look at that in the slides to come. And you also need to know a standard question they always ask you then. Now that you know how this system forms, when it forms, how does it then impact humans? How does it affect social and economic activities? How does it affect the environment? And after it has affected the environment, remember with impact you look at both positive and negative. Now if it affects us negatively, how can we then apply some precautionary measures and then management strategies in order to manage the effects brought by the system? So we think about that, very important. And then you need to be able, as I said, to identify these systems in a synoptic weather map. Remember, in a synoptic weather map, they will be demarcated by the eye. We'll do a question on that. And we must also be able to show how these systems are arranged in a satellite image. You'll be able to study the satellite image. They'll always ask you in which hemisphere is it in. So you look at the circulation of the air, so that you know in which hemisphere is the system at. So those are some of the important things that you need to know. And since we said these systems are named, let's just recap quickly. They are named alphabetically. Then you need to know in each hemisphere, what names do we use to describe them, so that if they ask you that, you're able to identify that in the examinations. And again, if they give you a case study, you need to be able to answer questions on it, on one of the most recent tropical cyclones. You can think about how we were most recently affected by tropical cyclone Eloise in the 20th, around the 20th of January this year, 2021. We were affected in South Africa by tropical cyclone Eloise. So you need to be able to answer some of the questions on a case study kind of questions on that section. So let's just look at the naming in the different hemispheres. Okay. Now, in the different hemispheres, we give tropical cyclones different names, right? Now, in the southern hemisphere, we call them tropical cyclones. And why do we call them that? It's simply because they form in the tropical regions. And we said that they are cyclones, which means they are low pressure systems. So they are low pressure systems forming in our tropical regions. So that's a very important point to note. And we say they form 5 degrees outside the equator, 5 to 30 degrees outside the equator. Very important point. Now, in the northern hemisphere, we call them hurricanes. And why do we call them that? Simply because, Americans like to be fancy, so they will use these fancy names. It simply means it's still a tropical cyclone, but the name is associated with the conditions that come with it. And then you get some eastern parts of Asia, they call them typhoons. So that's another name that we use to describe them. And if you look at the diagram over there, it shows us that we what's this? They occur at different parts of the different times of the year, and you must know that across the globe they always affect us late summer, early autumn. So you just have to work around the dates. If they gave you a case study kind of a question, you need to work with that and try to rationalize in which hemisphere is it at, depending on at what time of the year is it affecting us. So let's just also look at a cross section then of how do you identify these systems. Okay, then we look at the next part, which is our cross section. Remember that determination to draw a cross section of a tropical cyclone. You're supposed to draw something that looks something like this. Now, if we just study it briefly, you can see that what I was explaining, that for a tropical cyclone to form, we need an ocean surface at first. So this is our ocean surface here, and we have rising air in the ocean, and we say that because of the Coriolis force, this air is deflected sideways. And what does it do? At some point it rises, and as it rises, this is what we call convection, right? As it rises, it cools down, and means that it's gonna condense, form your thick cumulonimbus clouds, as you can see here, and along the sides. And what's going to happen to this air when it gets to the top? As it is cooled, it's going to form our cold air. And this cold air, remember that cold air always diverges. It's going to diverge at the top, as you can see, as shown by the arrows. And remember, most of the air that is filling up the upper atmosphere is cold air. And this cold air is going to do what? It's going to sink and enter the system. And we say that as it sinks, it warms up adiabatically. And what does adiabatic heating mean? It means that for every 100 meters the air travels downslope, it's going to increase in temperature near 1 degrees Celsius. So that's what adiabatic heating means. For every 100 meters the air goes downslope, it's going to increase in temperature with 1 degrees Celsius. And that is what we call adiabatic heating, which means by the time that this air reaches the lower surface of the earth, it will have been hot, yeah, or warm air. And remember, looking at the moisture content of the air, remember it is cold air that sank from the atmosphere. It means that in moisture this air is still dry, so it forms our hot or warm dry air. And that's why we say that in the eye we have stable weather conditions. They are stable because there's no water vapor of some sort. The air there is dry. That's what we mean. So when we are experiencing the eye, that's what we mean, and this is how your cross section will look. And in the exam again, they will always ask you about the dangerous semicircle, and we say that the dangerous semicircle is just a section of the tropical cyclone, as you can see here, that is associated with severe strong winds, and it's usually from the eye wall in your first vortex. It's usually found there in the western side of the eye wall, and it's usually found there in the southern hemisphere. And we say that this semicircle is associated with severe storm surges, severe rainfall, strong hurricane or tropical cyclone winds that extend to above 300 kilometers per hour. So you need to also be cognizant of that. They will ask you about that in the exam. And another guideline, guys, if they ask you then to draw a cross section of a tropical cyclone, you draw what you see on the above. You don't draw the bottom picture that I've hidden. You draw what you see on the above visible diagram. Make sure that you remember that. Cross section, that's what you draw. Okay, so I hope you are fine with all of that. We can then move on to looking at how do we analyze graphs, a graphical representation of weather patterns associated with your tropical cyclone. Now, if you look at our diagram here, let me get a laser. Now, you need to be able to look at your set of axes. Né? Now, you see that in our x-axis, we have what? We have time, right? We have time. We have 0 hours, 6 hours, 12 hours, 18, 24, 30, 36, 42, and 48 hours. So that's our x-axis. And then on the sides, on your y-axis, we have different features being demarcated. So on the y-axis, that is on the right, you have your wind speeds that extend from 0 kilometers per hour to 250 kilometers per hour. And then what else do we have? We have our rainfall. So our rainfall is in millimeters. So this dark section of the graph shows us your rainfall. Remember that, very important. And the dotted line is showing us our wind speed. And then we have temperature. So we're looking at temperature of this ocean. Remember, that's the temperatures we're talking about. Now, temperature in the ocean is demarcated by this solid line. That is here, this thick solid line. And then we have pressure there at the top. So that is demarcated by your thicker dotted line, right? And we measure, this pressure is measured in millibars. Now let's interpret then this graph. So remember, for you to interpret a graph, they give you one, you need to look at the features and the information that is given to you in your graph, the labels thereof. So we see that they say here we have subsiding air, right? This section of the graph. Now let's just read the graph from the left to the right. Remember, we read it from the left to the right always. Now let's look at what happens. Now we have a temperature that is between 25 and 30 degrees. I hope we can see that here when the graph starts. So we can say the temperature there is roughly 26 or 26, we can say it's roughly 26.5 degrees Celsius. And we see that over time this temperature increases to up to 30 degrees Celsius. Now, as our temperature is high over here, what is happening to our pressure? Our pressure is slightly decreasing, right? Yeah, so it shows us the relationship between temperature and pressure. Remember, when our temperature is high, the pressure is low. So if you look at the pressure, it's a declining slopey line of some sort here, because pressure and temperature are always opposite to each other. They are always antagonistical to each other, or they are always inversely proportional to each other. And then what happens when our pressure then starts to our temperature rather starts to drop here to below 25 degrees Celsius. We have rainfall that is below, or rather up to 10 millimeters, and on this side we have rainfall that is or rather pressure that is slightly declining, still at that point, and our temperature keeps on decreasing and decreasing as you move along the graph. And you see that at some point our wind speed starts to shoot up, and if you look at the graph there, our pressure starts to slightly increase a bit, so wind speed starts to shoot up, and then our pressure drops significantly here towards the center, and we say that at the center we have subsiding air. And if you look at your wind speed, as this pressure subsides rapidly downwards, we have our wind speed shooting up to the highest point. And when you look at your rainfall, you have the highest rainfall then at going up to 45 or 50 millimeter. So that's what happens. And then at the center of the system we have subsiding, and where there is subsiding air, you see that the temperatures are at 30 degrees, so we have slightly higher temperatures this side. And this tells you that there's something happening with the subsiding air. So what is happening is adiabatic heating. So as air sinks, it heats up adiabatically, and that's why we have a significant increase in temperature here at the center of the system. At the center there, we call it the eye. Let's remember that. And in terms of what the diagram is actually showing us, after this, you see that your temperature starts dropping significantly, and it's along these walls separating the subsiding air, if you can see that. And we have your highest rainfall, but you see that the rainfall does not compare to the rainfall in the first part section of the graph before rather 24 hours there. And you see that what happens is that soon after that, after some time, we have our rainfall dropping significantly downwards, and again you have your pressure starting to increase significantly that side. And then if you look at your wind speeds, it also starts to decrease significantly until they go back to where they started before. Now, what is this diagram actually showing us? The diagram here is a graphical representation of weather conditions associated with the segments of a tropical cyclone. Now, this first part of the tropical cyclone is what we call the first vortex. So our first vortex is the sun, and this second section of the tropical cyclone is what we call the second vortex. Very important. It's very important to think about that. Now, again, since we have established that the two parts of our system are showing us your first vortex and second vortex, where we have our subsiding air, that is where you get your eye. So that's where the eye is, and we say that the eye is associated with stable weather conditions. And why are they stable? It's because we have subsiding air. And what kind of air subsides? It is cold air. Cold air always sinks, always descends, always subsides. And we say that as this cold air is sinking, what does it do? It warms up adiabatically. And that's why we have in the section of the temperature, our temperature shooting up or increasing in that section of the graph. So it's something very important to think about. And again, another feature that we think about is what happens to the pressure. When your temperature then starts shooting up, you'll notice that your pressure decreases significantly. It's because at the center of the system where you find your eye, you have the lowest pressure, the most intense pressure there. And you see that your pressure is 925 millibars. So you have your lowest pressure at the center of the system, while on the sides you have the highest pressure. And that's why we say when you have your first vortex coming to affect us, you will have your temperatures decreasing, and when they decrease, it means that you'll have a slightly higher pressure. Remember the relationship between temperature and pressure always, it always acts the same way. Now if you look at your rainfall levels, we say that in the first vortex, you find your dangerous semicircle, which is associated with the most severe storms. And if you look at your graph, your rainfall goes up to 50 millimeters, and that's the highest rainfall possible. While in the second vortex, even though we have rainfall and pressure that is high and all of that, you see that the rainfall is slightly lower. It's roughly about 40 or 45 millimeters. And that shows you that the most strongest section of a tropical cyclone is the first vortex, while the second is slightly weaker, and that's why it's as strong. It has the same impact as the first vortex, but the impact can be compared to B, it's a bit minimal as compared to that of the first vortex. So that's an important point to think about. So these are some of the features that you need to understand. Now the arrows, again, remember that, guys, arrows are not for fun in geography. They are used to show direction of something. If it's geomorphology, they tell us the movement of water, for example, and they are used to label certain features in our diagram. So this arrow here is showing us the directional movement of a tropical cyclone. And remember that tropical cyclones form in the tropical easterlies or in the tropical easterly wind belt, and they move from east to west as a result. So that's why the directional movement is from the east to the west. So that's an important point to note. And guys, I'm still writing with my mouse, but I hope my writing is improved a bit today. Okay, so important point to just think about. Now right now I want us to then think about some of the questions they may ask you. So we're gonna start with some key multiple choice questions, and then we'll move on to the longer questions. Okay, so we are going to be looking at matching column questions. They always give you those. So that's how they can question tropical cyclones, or they can give you a multiple choice. So either way. So remember in the previous session, we looked at a multiple choice and how to answer it. So I felt in this session, let's just look at some skills that you can apply when you are working with matching columns questions. Now, these are some of the tips to answering matching columns questions. Now, there are two methods really that you can use. Let's look at the first method. Now, remember that geography is an conceptual subject, which means it's a concept-based subject. It means that you need to know your concepts. Now, with mid-latitude cyclones, there are special concepts or words that are unique to mid-latitude cyclones. And with tropical cyclones, same applies. There are special concepts that are unique to tropical cyclones. And we say that you need to know your definitions, you need to know your concepts. Because in your matching column questions, they will always ask you to match a description, which may be a definition or a description of some concept, and associate it with the correct term that will be in the other column. So thus you need to know all your concepts associated with each of your topics, so you are able to answer the questions. So we say that in a matching column question, always start with identifying answers for questions you are 100% knowledgeable of. So if you are given a set of descriptions, just try to match concepts that you know that you are knowledgeable of, or you're 100% sure of, and that will leave the ones that you are unsure of. Then you can use the elimination methods to remove the concept that doesn't apply to the description, or the description that doesn't apply to the concept being asked, depending on how they arrange it. Now, if you do that, you'll then be able to cancel out the option that doesn't apply and be remaining with the most correct one. And remember that you need to put your content cap on when you are doing your elimination method, so that you remember what set of thinking and reasoning is used to justify why an option is correct and why the other one is wrong. And then here's another method. So another method is to put your content cap on when you meet up with a matching column questions, and then focus on column 1, and it's usually the descriptions column. So read the descriptions given with a pencil on your question paper, underline the keywords they are asking you, and write down what you think the most correct answer is before you look at the second column with the options. So establish for yourself which concepts relate to the descriptions. Then afterwards, then you can go to column 2 and check if those options appear, and fill in the ones that you are unsure with. So check if the concepts you wrote are there in the second column, and then you'll be then able to check the correct answers and get a total for your matching columns question. So these are some of the tips that you can apply for any topic, be it geomorphology, be it settlement, be it economic geography. So always approach matching columns question in that way. Think about these two methods and find the one that works for you. And sometimes one may work in a certain situation. If let's say you know all your concepts, then method 2 can work. But if you're not sure about your concepts, then method 1 can work for you. So find the method that works best for you and use it for examination so that you ace those exams. So let's look at the questions. Okay, it says 2.1. With reference to tropical cyclones, match the term in column B with the description in column A. Now it says write only the letter A to I next to the question numbers 2.1.1 to 2.1.8 in the answer book. An example is they've written the 2.1.9, it's J. Now why is it important? Why am I reading this? In your exams, you need to be able to follow instructions. Always leave, remember, always leave a space between your responses. Always use the numbering system, the numbering guideline they issue in the instructions, so that you get your marks. If you make your own numbering systems, you do not get the marks. So make sure that you follow those guidelines. So let's look at the statements there. Now we're gonna apply method 1 and 2 for this. Now it says column A, 2.1.1, it provides energy that contributes to the formation of the tropical cyclone. What provides us with energy for the tropical cyclone? And you'll remember that when you look at energy, we are looking at different kinds of energy that exist on Earth. And in climatology, we talk about heat energy as there's one of the most important energies we talk about. So the system, or rather what provides us with energy, or provides the system with energy, will be your latent heat. So the answer is E then. Yeah? So the answer is E, 2.1.1. The answer is E. And why is it heat energy? Think about the example of you cooking a beef stew. Remember that for the stew to be cooked, we need to have a stove feeding us with the heat. So for a tropical cyclone to be formed, we need to have the ocean water storing heat in it, and this will allow for the heat, or rather for water, to evaporate or vaporize and convect as it goes upwards, condense, form our cumulonimbus clouds, then we'll have the formation of our vortexes. So that's an important one. And you see that I applied my content cap on, I put it on to try and give some reasoning behind it. And then 2.1.2, the local name given to a tropical cyclone in Southeastern Asia. Now you'll remember that I showed you a diagram of the world, and I showed you that in Southeastern Asia, we usually call our tropical cyclones typhoons. So the answer there is F. Usually call them typhoons. Next question. The state, or rather it says 2.1.3, cooler air sinks and there is no rain in this section. Just some important, it says cooler air sinks, there is no rain in this section of the tropical cyclone. We know that that is our eye. Remember that we covered that in the eye, conditions of the eye, there are stable weather conditions, means that there is no rain, no cloud cover, there is cool or cold sinking air, and as it sinks it warms adiabatically within the center of the cyclone. So the answer is 2.1.3 is G. Okay, next one, the stage where cooler air flows into the tropical cyclone, increasing the pressure. So when we have air flowing into the system, cool air flowing into the system, increasing the pressure. So that stage, we call it the dissipating stage. Let's remember that. We call the stage the dissipating stage. Now in the dissipating stage, why am I saying dissipating stage and not mature stage? It's because in the dissipating stage, we have an increase in pressure. And remember that the increase in pressure is the one that leads to the system being destroyed. So that's why the answer is A, dissipating stage. And then 2.1.5 says pressure drops to below 1000 hectopascals and winds speeds increase to approximately 120 kilometers per hour in this stage. So for that answer, our answer is C, and that is in the immature stage, because our pressure is below 1000 hectopascal, and again our wind speed increased to 120 kilometers per hour. While remember we said in the mature stage we usually have winds extending to up to 300 kilometers per hour. So 120 kilometers per hour is just slightly lower. So that's in the immature stage. And then 2.1.6, the stage characterized by a well-developed forward left quadrant, and that is our mature stage. So that's when we have our quadrants. So remember, quadrants are also called vortexes, your first and second vortex. 2.1.6 is I, mature stage. And 2.1.7, the stage where the pressure is above 1000 hectopascals and the tropical cyclone starts to develop. So which stage does it start to develop? So that's in the formation stage, the formative stage, that is D. That's where the tropical cyclone starts to form. And 2.1.8, created by the upward spiraling movement of air around the center, is our eye wall. Remember, our eye wall is formed as a result of the spiraling movement of the cyclone. So that is B. Okay, so that's what you need to do when you're doing column questions. Remember those two methods, and again remember your content. Even though it's short questions, you need to have reasons why are you saying this is the correct option and that one is wrong. Let's always remember that. And you'll see that we have one answer that is a distractor, which is H, being a hurricane. Remember, a hurricane is just the name for a tropical cyclone in northeastern, in northeast, was this in the northern hemisphere, on the west side, on the western side of, or in America, they call them hurricanes. It's still a name for a tropical cyclone. Okay. And then let's think about then long questions. So we're just gonna look at some of the long questions now. And again, some tips on how to answer them. We explored some of the tips in the previous session. Remember that for long questions, we need to first put your content cap on, which means you need to bring back all the content associated with the topic. Study the annexure first thoroughly before you go and start the questions. Study the annexure thoroughly and try to predict what will they ask you in that section. Read all the questions carefully. Highlight action words. Action words, do they want you to define? Do they want you to explain? Do they want you to account, describe, draw, illustrate, demonstrate? You look at those action words. What do they want from the question? Also take note of the mark allocation. If it's 2 times 1, it means that you need to give 2 responses worth 1 mark each. So also take note of the mark allocations for every question, and then think about how will you approach the question, and then you will be good to go for it to answer the question. So let's look at our first question. So now the first set of questions that we will be looking at is map kind of question. So it's a map depicting pathway of a tropical cyclone. So this is an extract from the November 2020 NSC Geography examination. So we have our annexure there. So it says figure 2.3, refer to figure 2.3, which shows the path of a tropical cyclone. And since they are saying it's a tropical cyclone, they automatically tell us that it's in which hemisphere? It's in the southern hemisphere. Okay, and then if you look at your map, you have the key there. So take note of those features there. We have the key. So it says part of the tropical cyclone. The part of the tropical cyclone is demarcated by the dotted lines and the solid lines over there. And then we have the date and the time demonstrated by the arrows over there. Those arrow kind of features on the map. And we see that this cyclone moves from A to B, and at different dates is found at different locations. So also take note of that. And you see that it is going towards Mozambique, so it's on the Mozambique channel, as they say over there. It's on the Mozambique channel. So that's our tropical cyclone there. Now let's look at what questions did they ask us. First question: give evidence that this tropical cyclone is in the southern hemisphere. Now, if you look at your diagram there, you look at how is your eye shaped. That always gives you a clue. Now, if you look at your eye, it's shaped something like that. In a way, it's shaped something like that. So that shows you that our air is circulating in a clockwise direction. So we have the air circulating in a clockwise direction, and tells us that it's in the southern hemisphere. And if you look at the date again, it is April, and since it's April, it's telling us that it is late summer. Remember that the tropical cyclones affect us late summer, and it's usually late summer, early autumn in the month April. So remember that point too. And then it's also on the Mozambique Channel, and also next to Madagascar, Maputo, Tanzania, Zambia, and all of these are countries that are in the southern hemisphere, or regions in the southern hemisphere. And it develops over the Indian Ocean, the southern Indian Ocean. So that also tells us that it's in the southern hemisphere. So let's look at the next question. Why is Mozambique channel usually ideal for increase in temperature within the tropical cyclone? Now remember that in the Mozambique channel you find which ocean? You find the Indian Ocean. And in the Indian Ocean, which ocean current do you find? You find the warm Mozambique ocean current. And the warm Mozambique ocean current is associated with warm air that is full of moisture. And is that not unique or ideal for a tropical cyclone to form? Yes, it is ideal because that's one of the recipes that we need for a tropical cyclone to form. So the warm air temperatures above the sea or warm ocean, which are above 26.5 degrees Celsius in the Mozambique Channel, ensure that we have constant or rapid evaporation taking place in that particular region. So that's one of the reasons. And again, the Mozambique channel is located closer to the equator, so it's in our tropical region, so that's also ideal for the formation of tropical cyclones. And the Mozambique channel is in the Indian Ocean, which is warmer because of the warm Mozambique ocean current. And let's look at the next question. Explain how the intensity of the tropical cyclone increased as it moved from area A to area B. How did the intensity of the tropical cyclone increased as it moved from area A to B? Now remember that as the cyclone is moving from area A, which is here, to area B, it's notable that as it moves over the warm ocean, its temperatures increase rapidly, right? And as its temperatures are increasing rapidly, we say that we have the conversions of air that goes to the atmosphere, and as it goes up to the atmosphere, it cools down, right? And when it has cooled down, it diverges, with air diverges, because cold air diverges, and at the center of the system we have air starting to enter into the system. So we have the intense low pressure forming at the center of the cyclone, and as a result, the intensity of the tropical cyclone as it moves from area A to B will increase. So it will be increased because of the moisture that the cyclone is exposed to as it moves over the ocean, and because of rapid condensation as a result. And remember, in the ocean we have latent heat, which is ideal for a tropical cyclone to be cooked or made. So it is released from rapid condensation, and it provides us with energy for the system to move rapidly from area A to B. And again, we think about the intensity of the winds. So we have a change from gale force to hurricane intense winds that move over there. And we say that because of the change in wind speed and direction, we have these strong winds that have a humongous effect over the regions in which the cyclone is going to pass, and they may cause coastal flooding, because the flooding of coastal regions, that's one of the changes you can observe. And we have developed tropical depression into a tropical cyclone. So it moves from being a tropical depression, tropical storm, to being a tropical cyclone, a well-developed tropical cyclone. And we say that the eye is fully formed at the center, and as a result of the decrease in air pressure as towards the center of the system, and area covered by the eye is increased in size. and we have a rainstorm increasing at the eye wall leading to the forward quadrant approaching. So A is again the only, or rather A is only a storm without an eye, while B has an eye. And remember, we say that at A, the region covered by the eye extends. Why? Because at A, remember that we have cold air coming into the system, and we know that on the sides, on the eye walls, on the sides of the system, as this air rises, this air is warm, right? And we know that warm and cold air never mix, but they meet at some point. Where do they meet? They meet at the eye wall. The cold and the warm air meet at the eye wall, and because they never mix, um, as this cold air sinks into the center of the system, it causes the warm air to be pushed sideways, and that extends our eye to a bigger size. So that's exactly what happens. It's because our cold and warm air never mix, and that's why we have that extension being observed. And again, pressure continues to drop as it moves towards B. So pressure is intensified as a result. Okay, then we think about 2.3.4. It says discuss the conditions that could have caused the cyclone to weaken as it reached area C. So what may have caused the cyclone to weaken as it reached area C? Now remember, C was on land. So as the cyclone moves on land, there is less moisture, there's no source of moisture rather. So the source of moisture is reduced as it moves on land. And on land we have friction. We said that a tropical cyclone needs to form in a frictionless surface, a smooth frictionless surface, and the ocean is ideal for that. But area C is the terrestrial region, terrestrial ground, so we have friction over there. And what else? As it moves away from the warmer waters, it's going to uh, decay or be destroyed. And why? It's because cold, dry air enters the system from the land. Remember that in the ocean, we find our latent heat there because it's heat stored in water, while on the land, we have what we call terrestrial heat. And remember again, on the land, we have our influence of high pressure systems over there. And again, remember the Kalahari is always on the land, it's a permanent high pressure, so it might have some impact on it, but we don't talk about it. Hypothetically speaking, it has an impact, but something to focus on is that this cyclone moves away from the warm oceans, so it gets into a colder region than the ocean, and as a result cold air starts entering the system. And again, as the air that enters the system is cold then warm, that leads to the start in the increase of pressure, and as a result the system gets destroyed. When pressure increases in a tropical cyclone, we have the system being destroyed. And then again, says evaluate the physical. Remember, when we talk about physical effects, we talk about natural impacts, and they were specific to say negative, ne? Remember that when they don't say, if they just say this evaluates the impact and they don't tell you is it positive or negative, you need to put in two negative, two positives, a paragraph question, or give one negative, one positive. Here they said talk about the negative impacts of tropical cyclones along the coastline of Mozambique. So here's the first response. The coastline of Mozambique will be subject to wind, water erosion, which will reshape the coastline. Remember that tropical cyclone are associated with extremely strong storms, winds that extend to about 300 kilometers per hour. So that may cause the ocean to be wild and strong, and it may cause Remember, they're associated with storms that may cause water to rise above sea level, and it may cause flooding in the coastal regions, which may reshape those areas because of these strong winds and this massive water that comes as a result of the tropical cyclone. And again, more coastal rocks will become exposed, limiting human activities. Strong winds and torrential rain will destroy sand dunes which have been there, which are essential for ecosystem biodiversity. Remember, we're looking at the negative impact, the natural negative impact. So if we had sand dunes that that have animals living on them, because of these strong storms and stuff, the biodiversity is going to be destroyed. The natural vegetation will be destroyed, because you might have observed that when tropical cyclones affect, we usually have trees being uprooted from the ground. So one of the impacts shows that the system is very strong, very intense, very massive, and has detrimental effects on the general environment. So very important point to note out. And again, we say bay areas along the coastline will become shallower. So they become shallow as a result of excess silting and restrict development. So the areas become shallow, not suitable for settlement, and that may block waterways. Remember, when a tropical cyclone comes, it will have flooding, everything floods, and water systems and pipes will be destroyed as a result of this, because even trees are uprooted, so they may damage pipes, destroy the water quality as a result. And we say that the coastline will be steeper and become inaccessible to tourists, becomes steeper. Why? Because it is deformed as a result of the tropical cyclone, so it is eroded severely, and that may make it to be. Let us look at some satellite imagery questions. I hope we are fine with image-based kind of questions, and don't be surprised about the change in dress code. I'm recording the rest of the video on a different day, so but the content continues. We're still doing tropical cyclones. Okay, now let's get to the questions. Okay, so question 2.4 says, study figure 2.4 based on hurricanes. And remember that with every examination, I always urge you to first study your annexure. So you are expected to do the same for this question. Study your annexure. Now in the annexure, as you can see, we have a satellite image of a hurricane, as they said there, figure 2.4 hurricane. Now if you look at our hurricane, we have point A to B. Now our point A to B is in a way a representation of what we have, or how long in diameter our tropical cyclone is. And you'll see that there are three sections to it. So we have the fragment from A to the I, and from the I to point B. So we have three fragments, and we call the fragment from A to the I the first vortex. We call it the first vortex. And you find that some study guides or textbooks will use the word quadrant. So that's the first quadrant or the first vortex. And you'll find your I here at the center. So that's our second part for our tropical cyclone. And from the I to B, we call that obviously the second vortex. So it in a way it shares the same name. Now, in terms of characteristics, we usually say that the first vortex is more intense and is associated with severe storms that are more severe than the second vortex. And we say that in the first vortex or first quadrant, that is where you find your dangerous semicircle or your dangerous quadrant. It is found here in the first vortex, just in a section closer to the eye wall, so that's where you'll find your dangerous semicircle. Now if you look at the diagram below, they are showing you a set of axes. We have point A to B, and we have in the x-axis, and in the y-axis we have an altitude in kilometers, extending from 0 to 20 kilometers, and this is showing you how long in height our tropical cyclone is. Remember that the x-axis, or the point that is here in our x-axis, that is your ocean. So you'll find your ocean over there, and we know that our tropical cyclones extend from the ocean going upwards. Yeah, so I hope you understand that, and we know that in some section of the cyclone we'll find our eye there, and you need to know the conditions of the eye and know the associated weather thereof. So those are some of the conditions that you need to know, and this is an extract from May-June 2017 Geography Senior Certificate Examination. So let's just look at what are some of the questions do we have for this question, because you notice that they gave you the cross section, which means they won't ask you to draw the cross section, and they also gave you two vortexes and a to B, so they may ask you to label that if possible and give some characteristics. And again, if we look at the circulation of the clouds before we just go to the question, we'll see that our clouds are going towards that direction, and that is an anticyclonic circulation. And we know that low pressure systems, remember a tropical cyclone or a hurricane is a low pressure system. We know that all low pressure systems circulate in an anti-clockwise direction in the northern hemisphere. So this is telling us that this cyclone is in the northern hemisphere. So the circulation tells you that. Okay, and voila, the first question comes. Give evidence that suggests that conditions shown in the satellite image occurred in the northern hemisphere. As we said, we have an anticyclonic movement of air along the low pressure, and that shows us that it is in the northern hemisphere. And you were told that that is a satellite image of a hurricane, and we know that in the northern hemisphere, as in America to be specific, they call tropical cyclones hurricanes. So that's another piece of evidence. So hurricane is the name that is used over there. Now, what is the approximate height of the clouds around the Earth? So they told you the approximate heights, 15 kilometers to 70 kilometers. Remember, your set of axes showed you the tropical cyclone from 0 to 20 kilometers in the y-axis, and you just have to identify from up to which point does your height extend towards in terms of the cloud. So and again, for you to be able to do that, you'll have to be able to identify the clouds from the diagram first, and then try to give a statistical or rough number of how tall in terms of height the clouds are. So that's what you need to do. And in 2.4.3, they said account, very important. Account is our action word. Now, when you're asked to account, you're asked to give a reason for why something is happening the way it is happening. You give an account for that. And we say that now, looking at the question itself, account for the lack of clouds in the eye. Now we know that in the eye, or rather our eye is formed by different conditions, right? We know that for the eye to form, we have first, or rather for the cyclone to form, we have first the convergence of warm air in the ocean floor, right? So when after this air converges, remember it converges as a result of the Coriolis force. Coriolis force causes a deflection of winds. Remember that. So our clouds, or rather our warm air, is going to converge. And remember, it's warm air, right? So it always converges. And after it converges, it's going to do what? It's gonna rise, because warm air always rises, right? And after it has done that, it is going to cool down. Remember, as it goes up, as this air rises that is full of moisture, it is going to cool down. And why does it cool down? It's because the higher you go, the colder it becomes. And as a result, by the time it gets to the top of our atmosphere, it is going to be cold air, and cold air always diverges. So it's going to diverge. Diverge means going opposite direction. Diverge means dividing. So it divides or goes to opposing direction. And if we may ask you, which air is dominating the upper atmosphere? It is cold air. Remember that, because the higher you go, the colder it becomes. So cold air dominates the atmosphere, which means that when the two air masses diverge, we will have now our cold air sinking towards the center of the system, and as it sinks, it's gonna warm up adiabatically. And as it warms up adiabatically, means that in the eye you are thus going to have this cold air creating stable conditions, as you can see in the slide here. So our subsiding cold air is going to create stable conditions, in a sense that we won't have cloud cover, we won't have cloud cover, we're not going to have winds or strong winds, we're not going to have any form of precipitation as a result. What we are going to have is just some warm air. And remember, this warm air is dry. And why is it dry? It's because it was cold air that is dry, filling up that was in the atmosphere, that has warmed up adiabatically as it was sinking. So that's why it is warm, and as a result we are going to have stable conditions, and that means we are not going to have cloud cover at all. So as they say here, rapidly rising air around the center of the eye results in upper air divergence, as I explained to you. So results in upper air divergence, and the cold air filling up the atmosphere is going to sink and warm up at the as a result. Now, what is the source of energy that drives this hurricane? We know that the source of energy of the hurricane is heat. Remember that for hurricanes to form, we need temperatures that are above 26,5 or 27 degrees centigrade or Celsius. So we need to have temperatures that are above 26,5 or 27 degrees centigrade or Celsius. Yeah, so that's what we need. So the source of heat. So because the sun hits the water or ocean surface, we thus have latent heat. And we say latent heat is just heat stored in water. Heat stored in water is latent heat. So this latent heat, remember, we're gonna have these temperatures because of that. The heat we will have now rapid upper air rising, and as it rises, convection happens, and that leads to us having this warmth being distributed towards our atmosphere. So latent heat is the source of energy. And remember, heat is released during condensation. So as I said, we have latent heat leading to rapid evaporation of heat, and convection will happen. Convection is when air goes up to the atmosphere, and as it goes up, it loses its heat, and when it loses its heat, it doesn't become water vapor anymore. It turns back into water, and it thus forms clouds, and we are gonna have the two vortexes forming and rainfall as a result. Okay. It says describe the type of weather conditions that surround the eye. Now remember the keywords. Remember to always look for the keywords. So number one, the action term says describe. You need to describe, right? What are you describing? You are describing weather conditions. And where are you looking at these weather conditions? Is it in the eye or around the eye? So you're asked to look at the conditions that surround the eye. So don't talk about the conditions in the eye, talk about the conditions around the eye. So remember, what is around the eye? It is your two vortexes, the first and the second vortex. So you need to talk about what weather conditions exist over there. And we know that in along the eye goes back to our simple diagram. So remember, your eye forms as a result of upper air, or rather warm air rising. So you're gonna have your warm air rising. So it first converges, rises, diverges, right? Converges, rises, diverges. So forgive me for the handwriting. I'm pretty sure we are now used to it, but it's way better than last time. And after it rises, we know that we are gonna have your cumulonimbus clouds forming, and they in turn form your vortexes. So we have your cumulonimbus clouds forming, and you know that in your diagrams they usually draw your smaller nyana cumulus clouds forming here and some sections of stratus clouds, but we focus on it. So you have your cumulonimbus clouds on the vortexes, and this is your first vortex and this is your second vortex. Now because we have cumulonimbus clouds, we know that they are associated with heavy rainfall, right? So you have heavy rainfall, so that's one of the weather conditions that you're gonna have. Thunderstorm, and when there's heavy rainfall, there's going to be wind. So you have hurricane strength winds, winds that go up to 300 kilometers per hour. Very, very intense, strong winds are going to be experienced. It is going to be really cold. It is going to be really rainy as a result of that, and we'll have things being washed away. So as you can see, that's exactly what happens because of the hurricane strength. So wind are going to reach hurricane strength. As we said, we're going to have a thunderstorm in the interior, intense heavy rainfall, and we are going to have spiraling of cumulonimbus clouds. So they spiral or they circle around. They're very thick and very strong as a result of that. So those are some of the conditions you have. And remember, you're going to have low air pressure conditions because this is a tropical cyclone. So it's a low pressure system. We are going to have hail, storms, and lightning. The walls of cumulonimbus clouds, which results in overcast conditions. These are some of the conditions that you are gonna have. I hope you understand that one. And then 2.4.6 says, draw a simplified labeled plan view sketch of the illustrated hurricane, clearly indicating the air movement around the eye, the dangerous semicircle or area where most damage will be caused when it reaches the land. So this is the diagram you should draw. Remember, they said a plan view sketch. So if it's a plan view sketch, they did not say draw a cross section, because remember, they had given you the cross section already in the examination. So in your annexure. So they are asking you now to give us a sketch, a rough sketch of what will happen. I hope we understand that one. So remember, at the center of your eye, of the system, you must have your eye. So you need to draw your eye symbol, and your eye symbol is simply you drawing a funny number 2 and putting in a dot on it. So that's basically your eye. Or you can draw an S and again put a dot on it. So that is your eye. And to be safe, if it's in the northern hemisphere, just to show the circulation, just draw the S shape, because it shows that air is circulating in an anti-clockwise direction in the northern hemisphere. So your I symbol will look something like that, just to show the hemisphere that it is in. And then with the southern hemisphere, your I will look like the number 2, the funny number 2 there, and it will be like the number 2, and your arrows will show, of course, that we are circulating in a clockwise direction. So you can draw your eye symbols like that to differentiate between the two hemispheres, and just to be safe. And then again, they said you need to show where the dangerous semicircle is. So you see that your dangerous semicircle is on the northeastern side of your tropical cyclone, and that's because that's where, in a way, your tropical cyclones originate from, because they move from the east to the west, so you'll have your most intense pressures. And remember, your dangerous semicircle is always in the first vortex, in a section of the first vortex that extends from the eye wall to that northeastern section over there. And the air movement, of course, will be anti-clockwise, because all tropical cyclones rotate in an anti-clockwise direction in the northern hemisphere. Okay, let's look at the next set of questions. We have synoptic weather map questions. So you'll have to analyze synoptic weather map and try to answer some questions on it. So I hope you understand how to answer questions on a satellite image analysis question. So they can give you that, or they can give you a picture diagram like we did in the first question, or they can give you a satellite or synoptic weather map question. So let's look at that. Now, study figure 1.3, so if study figure 3, which shows a synoptic weather map. Now, this is our synoptic weather map, and we can see that this is South Africa, and we can see that there are different systems that exist. Now, there is a tricky thing that is happening there. They can ask you in which season, what season is depicted in this diagram. So you need to be able to answer that question. Now, there are a lot of distractions, as you can see. For example, you see that your high pressure systems, you may use a laser, your high pressure systems are there in the interior. You have your South Atlantic high pressure cells and your South Indian high pressure cell. And then you have some mid-latitude cyclones approaching. One is far east, one is further west, and it's approaching the coast of Cape Town. And at the same time, you see that we have a low pressure in the interior, and on that other side we have a tropical cyclone that has a pressure of 992 hectopascals in the center. So these are some of the conditions that we can see from this diagram. Let us determine whether it is in the summer or the winter season. Now, because we have a tropical cyclone and we know when tropical cyclones happen, we know that they occur late summer, early autumn. So it automatically rules out a thought that this is showing us conditions that will be experienced in the winter season. So it shows us that, it rules it out. And again, we can also think about the location of your high pressure cells. So we know that in the winter season, always you'll have the Kalahari high pressure there at the center of the country dominating the interior. And we can see that we have a low pressure dominating the interior, and a specific name for the low pressure is a heat low or a thermal low. So this thermal low is dominating the interior, and these high pressures and stuff are just a distraction, and they are also a reflection of the fact that these occur late or early summer, late summer and early autumn, which shows you that it is towards the colder season. That's why your high pressure cells are approaching closer to the country, and your mid-latitude cyclones start affecting the country. But the season that is shown based on evidence, it's that it's the summer season. And we can see that it's a tropical cyclone because it has the I, and if you look at it, it has the name. Remember, they're named alphabetically from A, the first being A, starting with the letter A, going to Z, of course. And that tropical cyclone is Tropical Cyclone Haruna. So those are some of the features there. So let's look at what questions do we have. First question. The first question, they are asking you, does the map show a typical summer or winter condition? So this is showing us a summer condition. And why do we say so? It is because we have the tropical cyclone. It takes place or affects us late summer, early winter, early autumn, sorry. Now, 3.1.2, draw the symbol present on the symbol present on the synoptic weather map indicating the eye of tropical cyclone Haruna. So that is your symbol. It has to look like that. And remember that I said to be safe, draw the funny 2 to show the southern hemisphere. It shows you we have a clockwise circulation of air in this system. So that's what you can identify. Next question. What evidence suggests that tropical cyclone Haruna is in its mature stage? So we know that in what affects tropical cyclone mostly, it's your pressure. Remember that. Now when we have pressure that is well below 1000 hectopascals, we can then have a tropical cyclone that is in the mature stage. Now if you look at it, and then why is that important? Remember, in the center of the system where we have the lowest pressure, we have our air entering the system. And remember, this air that enters the system is our cold air. And why is it cold air? It's because this cold air moves from this atmosphere where the pressure is higher towards the center of the system where the pressure is lower. So it is following pressure gradient, a force that says air will always move from high pressure to low pressure. Now in the mature stage, we have that happening perfectly well. We have cold air entering the system at the center, and as it enters the system, it warms up adiabatically. And as a result of it warming adiabatically, we are thus going to have the formation of the eye. So evidence that shows us that it is in the mature stage, it is the intense low pressure number 1. They said the pressure is 992 hectopascals. And again, we have our pressure gradient being followed because pressure decreases towards the center. So you observe your lines in the synoptic weather map. Remember, this is derived from GDE seed material. You can just go back, rewind the video to look at the annexure again so you see what we are looking at. So if you look at your isobars, it is showing you that they are a bit closer together and pressure is decreasing towards the center following your pressure gradient force, showing that air will move from high pressure to low pressure, so it decreases towards the center. And again, we have the eye being fully developed as I had outlined. So those are some of your pieces of evidence. So let's look at the next question at 3.1.4. Describe the weather associated with the eye of the cyclone. We told you that to say because of adiabatic heating of the air as it enters the system, in the eye we are going to have no cloud cover, no winds, no rainfall or precipitation. So that simply means we are going to have stable weather conditions. So we have calm air or with no winds, no rainfall, no cloud cover. We have a low pressure. Remember, it's a cyclone. We have a low pressure at the center because air enters the system. Pressure decreases towards the center. And remember, the ocean surface temperature is higher than 26.5 degrees Celsius. And part of what contributes to that is the sinking air that warms up adiabatically. So those are some of the conditions that we have. So we call them stable weather conditions. 3.1.5, how do warm oceans contribute to the development of these cyclones? Remember, when we have warm oceans, we are thus able to have rapid evaporation of air. And when we have rapid evaporation of air, we can thus have convection as this air rises, and the convection leads to us having the formation of the two air vortexes. And remember, at the top of the atmosphere, where we have this warm moist air now being cold, and thus diverges, forming our vortexes properly, and we are thus going to have the formation of your cumulonimbus clouds, and as a result we have a fully formed tropical cyclone. So a tropical cyclone requires high levels of evaporation. Remember, as air evaporates, convection happens. So it's the upward movement of air. So that's how we define convection, the upward movement of air. So as this air rises, we have our tropical, or rather our vortexes forming. So again, latent heat is going to be formed, and as a result we'll have convection currents of warm moist rising air, which creates our cumulonimbus cloud. So those are the reasons that you give. Now 3.1.6, last question, suggest two precautionary or precautions the people of Maputo need to take within the next 24 hours. So remember, it takes 24 hours for a tropical cyclone to reach its mature stage. That's one information that you need to know, which means in 24 hours it would have gotten to Maputo. Now we are asking, what precautions should they take now to address the problem that is to come? Remember, when it gets to Maputo, it will be in its mature stage. So it's going to come with very strong winds, very heavy rainfall. And they will need to first have an evacuation plan to get people out of dangerous areas, and your dangerous areas may be your coastal areas. So people will have to be evacuated out of the coastal areas to avoid being flooded by the system. So rescue teams must rescue people from flooded areas. We need to have, again, a good early warning system. So the weather forecasting system is very important to predict the pathway of the cyclone, so that necessary precautions should be taken. Everyone needs to have organized some basic necessities they will need. They will need a first aid kit. They will need batteries for radio. Remember, they will have to listen to the weather forecasting so they know what is going on in case there's a need for them to evacuate. They need lamps and torches, because remember, the electricity system is disturbed during a tropical cyclone because of the strong winds. So some electricity poles may be uprooted and flooded away by the strong rainfall. And again, they need to stock up on canned food. Why canned food? It's because there won't be time to cook a full meal. Electricity won't be functioning properly. And again, it's a bad idea to light a fire. Remember, people in Maputo live in these rural areas, while some live in cities where they depend on electricity. So it won't be good for those with electricity to cook with electricity or electrical stoves, because the pose would be disturbed. And again, with people that use fire to cook, it would be a better idea to light up a fire because of the strong winds that may lead to fires and houses burning down if a mistake happens. And again, we need to place sandbags along rivers and coastal areas to reduce the impact of flooding. So in a way, we say sandbags are your flood breakers of some sort, because they assist us in blocking or reducing the effect of the flood. So they don't stop the floods, still floods, but if water will have to fill a certain point before it can pass into the interior. And again, erect wooden shutters on windows and educate people to stay away from windows and doors during the storm, because they may be hurt. So stay under a very hard surface. So some people choose to stay under tables. Okay, and the logic behind is that the table is strong and rigid, so they can be protected in case some things fly through the windows to the house. Yeah, so put those precautions, and that's how you address it. So you need to be in a position of being able to provide some of these solutions. So let's look at a diagram-based question on tropical cyclones. Okay, so the first step is to study your annexure, remember that. So this is figure 5, and you're asked to study figure 5 and answer the questions that follow. So this is showing us a cyclone, and they just said it's a cyclone, which means a question may come and ask you what type of cyclone is shown in this diagram. And you can see that we have spiraling air in this cyclone going in an anticyclonic direction. And as much as we have spiraling air, we have a section of that being highlighted, and I would like to assume that is our dangerous semicircle, right? And again, we will see that there is descending dry air towards the center of this system. So this is showing us that it's a tropical cyclone, and we have your first vortex that side and your second vortex this side. So those are the features we have. So let us look at the question that we have. First question, give evidence to indicate that the sketch shows a cyclone in the northern hemisphere. The evidence we have, we said it's the anti-clockwise movement or circulation of air. And again, the position of the dangerous semicircle is usually on the northeastern side, or rather that section of the cyclone. And again, 1.5.1. Name the section of the moving cyclone where the highest wind speeds are recorded. So we know that the highest wind speeds are recorded where? In the dangerous semicircle, or in the first quadrant or first vortex, where your dangerous semicircle is found, or you can just say it is in the northwestern side of the cyclone. So that's why you have your highest winds. Remember, the dangerous semicircle is known as dangerous because it has intense winds, strong rainfall. And that's why we say the first vortex is more detrimental in terms of effect than the second vortex of the tropical cyclone. 5.1.3. Give one reason why the descending or sinking air in the eye is dry. It is dry because in the upper atmosphere we have cold air, and cold air is always dry. It has no moisture, so that's why it is dry. And yeah, so that is that. So descending air does not condense, it remains dry. That's why we have that. And remember, again, because of the adiabatic heating of descending air, so this air remains dry. 5.1.4. explain why satellite images are effective for tracking cyclones. So this is like an application kind of a question. So you'll have to think about what are the benefits of having satellite images. So satellite images show you the diameter, number one, of the cyclone. They tell you how big the cyclone is. They also allow you to then look at what possible effect that may have on people, and again we are able to track the movement of the cyclone to see which areas is it possibly going to affect, so we can create evacuation plans and thus take necessary precautions to avoid the detrimental effects of the cyclone. So it says data can be received in real time. So again, with satellite image, remember they are a true reflection of what is happening in real time, so we can have accurate information being shared to the public, and data can be monitored every hour. In terms of that, data can thus help to determine the intensity trends of the tropical cyclone in terms of how strong it is. We can then predict again the pathway based on the observed trend to see which areas is it going to affect, and images can be used to better determine other information such as what speed, what temperature, and what wind direction is the cyclone moving. Satellite images are large and can allow for the monitoring of these cyclones in areas that accessibility. Yeah. So next question, write a paragraph of approximately 8 lines to outline. That's your action words. Outline what? The economic and the environmental impact of cyclones, such as the one in figure 5. Now, if you look at this question, it has 2 parts, and in the 2 parts they can further be broken down to other 2 subsections. Now you are asked to talk about the economic impact, and remember they were not specific to say is it positive impact or negative impact, which means for this question you need to apply your critical thinking in finding one possible economic impact and one possible negative impact, and then one environmental impact and another one positive impact on the environment. And that's why they said you need to give us 4 responses, each worth 2 marks. So very important guideline. Let's start with the economic impact. Now we know that these cyclones are going to damage or lead to damage to transport and communication structures. That's a negative impact. They may damage personal property or people's homes. They damage businesses, which is bad for the economy. And remember, when they damage property, it means that people have to spend money in fixing the property, right? And it causes a financial strain on people, families, and businesses. And insurance companies will have to pay now these people to fix their stuff. And it damages vegetation, crops, and livestock. Damages shipping, offshore and coastal structures, so bad for the export market. It is very costly to rebuild after a cyclone has occurred, and it thus has a negative impact on the GDP. Some businesses may be damaged, as we said, which means people may be unemployed. And however, as much as it causes unemployment in that case, a positive impact is that when the rebuilding process happens, that may create employment opportunities. That's a positive impact, right? And another negative impact is on tourism. Impacts negative on tourism may destroy some natural reserves, may destroy these attractive tourist sites. So It affects the trading of goods because ships are unable to travel and flights are not allowed to move, so that may be negative for them. And may cause food insecurity because it damages farms, remember that, vegetation, crops and livestock. So it may cause some food insecurity, and when people lose their jobs, they may not afford to get access to healthy, nutritious food, which is food insecurity. A positive impact again is that, let's say a city was very old and it hasn't been managed, then tropical cyclone hits. Now after it has hit, they are forced to rebuild the area and renew buildings and infrastructure, so the area will look way more better. So in this case, we can say the tropical cyclone is a force that prompted or that led to the renewal of buildings and infrastructure, which is something that may be looked at in the positive. Let's look at the environmental impact. So on the environmental, it may lead to the flooding of low-lying coastal areas, and those areas may erode, and we are thus going to have saline intrusion of low-lying coastal lands. So these areas will be eroded and unshaped or affected negatively. We can then have the spreading of waterborne diseases such as cholera. People drown and stuff, so may affect the quality of water and people may get sick. And we know that ecosystems are disrupted and food chains and food webs are destroyed. Let's say in the ocean, next to the ocean in that island, we had a lot of birds that depended on fish in that particular section of the sea. Now, these birds that eat the fish won't be able to eat the fish anymore, get access to the fish anymore. Why? It's because, number one, because tropical cyclone may affect ships. Let's say we have a ship that has oil or that transport oil in it, because oil is usually shipped. Now, this ship is going to spill all the oil in that water and the fish are gonna die. And what's going to happen? These birds are not gonna have access to food. You see that? So the food chain is damaged as a result. So the decrease in the bird numbers also decreases the food that the fish is going to have. So that's a negative, very, very negative impact that we can talk about. And again, we can also think about, in terms of damage of food chains, we can also think about how fertilized soil, fertile soil rather, is going to be washed into water bodies. So that may cause eutrophication, algal blooms, and as a result, the water bodies will be destroyed and water quality decreases, of course, and that may destroy food chains as people may be fishing the fish in that water, and as a result they won't have access to the fish anymore. So those are some of the negative impact. And again, silt is washed into dams, reducing their water holding capacity. So silt is soil that is washed into the rivers, and the water table, of course, will increase. That's one of the positive impacts on the environment. Okay, and then let's look at a different set of questions. This is an extract based question. We've covered, remember, a diagram, or rather a illustration kind of a question. We've covered a satellite image kind of question on tropical cyclones. We've covered a synoptic weather map analysis kind of a question. We've covered a cross section and just diagram kind of a question in different hemispheres, and we are now looking at a case study kind of a question. Now, first thing is that this question Institute Geography Study Guide that is going to be made public in the years to come. We are still constructing it. So these are some of the questions we have. So we have a question on tropical cyclone Eloise. So it says tropical storm Eloise, now a tropical cyclone, causes chaos in Beria. So that was an article that was written in 24 January 2021 by Peter Mbuyisa, that is me. Now, it says hundreds of citizens have been severely negatively affected and are scattered on the roads with nowhere to sleep in the city of Beria in this heavy worldwide pandemic as a result of tropical cyclone Eloise. The weather services depicted that gale force southwesterly winds were expected on Wednesday. There was a warning of very rough seas with waves up to 6 meters. A combination of very rough waves, strong winds, marine storm surges as a result of this was likely going to hit the Beria community after a few hours once again. Weather services advise that citizens be evacuated as soon as possible and not think the storm has passed. Now that is telling you something. There was a storm that affected a lot of people, and there is a short section now of time where there is no storm. So take note of that. And then it's a warning here to say citizens are warned not to think that the storm has passed, which means it has not passed, right? It is yet to come. Now, in the midst of all this, the farmers in northeastern Africa or South Africa are happy for the rain. This is bringing for them after a dry summer in the region. Okay. So that is what we have. So if you look at the diagrams here, we have a satellite image showing the storm, and we have label number or label letter A. So let's just analyze an enlarged image of it. We have A there being enlarged, and they are most probably going to ask you to label A, and A is the I. Remember that. And again, we have a satellite or kind of a forecast showing you how wind direction and wind speeds developed over time. Yeah, so that's something that you need to take note of. And this is an image that belongs to the ENCA news report. So they have all copyright on this diagram. We are just using it for educational purposes for your Matric examinations. So those are the features that we have over there, and we can see how this weather changes from Friday, Saturday to Sunday. So those are some of the features. Okay, so we can resume to the questions then. 2.1, how many cyclones, including Eloise, have occurred so far in this tropical cyclone season? Now remember that tropical cyclones occur in a sequence or in a series, right? And it means that since tropical cyclone Eloise starts with the letter E and they are named alphabetically, letter E is the 5th letter in our alphabet. So it means that 5 tropical cyclones have occurred so far, including tropical cyclone Eloise. And then 2.2, what evidence on the satellite image suggests that Eloise is a tropical cyclone? So we had the label A, remember that. So the label A is showing you that we have a tropical cyclone that has an I. So A is an I, so that is evidence to say that it's in the mature stage. And again, we have a circular band of clouds, and those circular bands of clouds are your cumulonimbus clouds, and the cyclone is named, so it has a name Eloise, which shows that, and we have a large diameter of the system indicated again as a tropical cyclone there. Satellite image, the date also tells you that it is a tropical cyclone because you can see that it's occurring late summer, right, and early winter, so it can't be another system. And again, it has the eye, as we said, and it is in the northeast coast of South Africa in the warm ocean, so it's not in the western side, so it can't be a mid-latitude cyclone, so it's a tropical cyclone. And again, we have the clockwise rotation of air, and we know that all low pressure systems rotate in a clockwise direction in the southern hemisphere. 2.3. Identify the stage of development of the tropical cyclone in the satellite image and describe its formation. Now, the stage of development of the tropical cyclone in the satellite image is the mature stage. And we know that in the mature stage of a tropical cyclone, pressure decreases to well below 1000 hectopascals. Basically, we like saying 965 roughly hectopascals or 995 hectopascals, depending on the stats they gave you. Again, we know that we have an intense low pressure, which means we are going to have the formation of the eye as a result of adiabatic, cold air heating up adiabatically. So that's what we're gonna have, and that's what happens in the mature stage. The mature stage, the pressure is well below 1000 hectopascals. There is a fully developed eye that is clear, cloudless due to cooler subsiding air that warms adiabatically. We have around the eye wall, we have vortexes well developed with intense cumulonimbus clouds as a result of rapid condensation of air. 2.4. Identify the feature labeled A and describe the weather conditions experienced there. We said that is the eye, and the eye is associated with clear sky, no wind, calm conditions. So those are the conditions we have in general. We say stable conditions. Name the cloud type around A and explain how it is formed. So you have 1 mark for naming the cloud type. That is cumulonimbus cloud. And you need to tell us how is it formed. So it forms due to latent heat in the ocean. So because of latent in the ocean, we have the rapid evaporation of water in the ocean, which leads to rapid condensation, which then leads to the formation of cumulonimbus clouds as a result of the convection of air as it rises. And that's what we have. 2.6. State 3 conditions necessary for the formation of tropical cyclones. Remember, we said think of it as a recipe. So in a recipe, for you to have a beef stew, you need certain conditions being met, being your pot, being the beef itself, being the veggies and seasoning things that you will need. Yeah, so and water and stuff. So that's what you need. For a tropical cyclone, you need the latent heat. You need an ocean surface that is warm with temperatures above 26.5 degrees Celsius or 27 degrees Celsius and above. We need to have your Coriolis force. You need to have our cyclone being between 5 and 30 degrees outside the equator. You need to have the ocean surface. As I said, ocean must be warmer than 27 degrees Celsius. If you say 26.5, that's still correct. You must say though above 26.5 to be specific. Now, hot, moist air, because of evaporation, unstable air, that will result in condensation. We need to have surface convergence of air, so we need to have warm air converging and then rising right up to form our 2 vortexes. So that's what we need. And again, you need to have intense low pressure enhanced by the tropical jets stream in the upper air, you need to have, remember the jet stream leads to our air pressure gradient or air moving into the system, right? And we need to have several days of calm conditions needed for the convergence of air. And we need to have upper air divergence to maintain a low pressure on the surface and to promote surface convergence. Very important. So those are some of the conditions that we need to feel. 2.7 account for the disappearance of Eloise after passing across barrier on land. Now, why does it disappear? Remember, on the land, number one, we don't have latent heat, but we have terrestrial heat or terrestrial radiation. So our system is going to disappear as a result of that. And again, we have friction. So as the system moves over land, we have friction. So it slows down the system. Yeah. And there is less evaporation on land further south. And why further south? In a way, it reaches the westerly wind belt, and then it's a bit colder than the tropical easterly wind belt. So that's why we have less evaporation on land. We have dry, stable air into the system. We have dry, stable air entering the system. We have the air pressure rising because the interior is more colder than the ocean floor that is warm. Again, we have less condensation, so less latent heat is going to be released. So those are some of the reasons that you have. Now, explain why people in barrier would not have been prepared for the chaos created by tropical cyclone Eloise. You need to give two reasons. Now, they have poorly constructed infrastructure and buildings will be affected. Remember, barrier is in Mozambique, and Mozambique is known as a developing country. It's a developing country, not a developed country. So let's take note of that. It's a developing country, not a developed country. And as a result of that, we have poorly constructed infrastructure, and buildings will then be destroyed. So that's why they may not be ready. And again, they have poor warning systems, and the warning again that was sent didn't really include the evacuation procedures that was sent on the article. The area is underdeveloped, as we said, lack of communication for pre-warning, limited technologies. Remember, there are people that live in rural areas where there is no electricity at all, no network connection of some sort. So that means they are not going to get information on time. And warning was for Monday and did not include Sunday. And if you look at your satellite image, it shows that on Sunday we'll have even more detrimental conditions. And why? It's because the storm surges are going to affect the region, and it is not late summer, so that's another thing. It is somewhere in the 24th of January, so it may come as an unexpected event because they will expect it to happen late February, early March. But now it is in mid-January, mid-summer, and they may not really expect such a system to affect them. And the last question says, write a paragraph on the impact of the cyclone damage on the environment and the economy of Beria and northern South Africa respectively. Beria and northern Africa, South Africa effect. We are going to have the loss of valuable topsoil, disruption of biodiversity, coastal wetlands will be destroyed as a result of this polluted water coming there, and trees being uprooted. Now we will have food chains being disrupted, pesticide and insecticides from the farms will be washed into rivers, damage and dams, damaging the water quality there, destruction of aquatic system, and again natural vegetation is going to be destroyed as some plants are uprooted by the strong winds. Now with regards to barrier and northern South Africa environment positive effect. So the flood waters would create new streams, so that may increase the drainage density, the average streams per unit area. That's again more. There will be more water for irrigation of forests and plants, and more water for animals in the dry northeastern South Africa. Because remember in the article they highlighted to say that it has been a very dry summer, so this system assisted in them getting water, so that is good. Now floods will cause some areas to have fertile alluvium. So remember that, for example, if there was a farm in a high-lying area and another farm in a low-lying area, all the fertilizers from the top farm or the fertilized alluvium will be washed into the bottom of the farm, and it means that that farm is now going to have fertile soil, which is good for farming. Yeah, so those are some of the conditions. Now again, we can think about barrier and not Southern Africa negative impact. We can think about how it can damage infrastructure, which is very costly to repair. It may damage bench fund properties, which will negatively affect tourism and economy. There will be a loss of crops, which leads to food shortages, and high prices will go up or higher. And remember, we will have more food imports than exports, so it's going to affect the export market. There will be a loss of fertile soil, which increases in production costs and rise in food prices, and there will be less income generated by farms, and therefore agriculture will contribute very little to the economy. Some people may die as a result of the storms and strong winds and houses being damaged. Industries that depend on the primary sector for the supply of raw materials will be adversely or negatively affected and will have to close temporarily till the problem is addressed. So you see it affects even the other sectors of the economy, and that may cause disruptions of water and electricity supply, as there will be damaged cables and pipes will burst as a result of the system, and will increase healthcare costs because the demand will be high for health services, so therefore the prices are going to go up. It will increase, an increase in insurance claims and costs as a result of storm damage, which may affect the health sector negatively. There will be job losses, so people may be unemployable. And again, we can think about some of the positive impacts that are specific to the North-Southern African economy. Since the region, according to the article, has not been receiving enough rainfall because of the tropical storm. So this storm is going to bring more rainfall and water for the region. And this enables the residents in the area to practice agriculture, which increases crop yield of the region, which is good for the environment and the economy, of course. And since it is midsummer, the cyclonic rainfall fills up rivers and dams of the region, which is good for the economy, as more water will be available in the winter season for farming. So remember, these storms are going to bring a lot of water, so it will cause dams to fill up, and there will be water then across the winter season. And remember, this is happening mid-summer, towards the end of the summer season, if you want to put it that way. And that will then have a positive impact on that. Yeah, so those are some of the reasons that we can have. Now, let us give you just some brief tips then. Tips for tropical cyclones. So for this topic, I hope we understand how to answer questions. Now, again, when you are revising, ensure you know the following. You must know how to answer the what question. What is the system that I am studying? So on the what is the system that I am studying, you need to know what concepts are special to tropical cyclones. For example, we talk about latent heat. We talk about the eye, the vortex. So you see, these are concepts special to tropical cyclones. So those are the concepts that you need to know and be fully aware of. And again, you need to know the characteristics on the what. What is special about the system? What effects does it have? And we also need to know now the where. Where does it form? Where does it form? And we say it forms 5 degrees outside the equator to 30 degrees outside the, and when does it occur? We say late summer, early winter. Do they affect certain regions and not others? For example, they wouldn't affect regions that specifically, they wouldn't affect the west coast, remember, because they affect the east coast because they come from the eastern side. See that? So they, by the time they get to the west coast, they will be destroyed. So and weak, they wouldn't affect the west coast, they affect the east coast. So that's what we mean. You need to know which areas do they affect, how do they form, how do they look. Remember, they have vortex, eye, vortex in a cross-section format. In a satellite image, they have an eye and circular band of clouds being your cumulonimbus cloud. And how do they affect humans, the economy and the environment? So you need to know that. And why do they form, where they form, and why do they have the effects that they have? So those are some of the questions you need to ask yourself. Now here is a list of references, looking at where did we get the questions we looked at in this session. So we looked at a question from the November 2015 final grade 12 geography question paper. So you can look at it for more questions on other sections and for a nouns understanding of some of the questions. The DPE May June 2017 senior certificate grade 12 geography question paper, November 2020 final question paper, and the latest paper is the final 2021 May June 2021 grade 12 geography question paper. And we have some questions from the Cybono SIP material, mindset, learn extra resources, and the PSI Pedagogical Science Institute Geography Study Guide that is still under construction, and that will be released for future grade 12s in due time. Okay, so I hope we understand tropical cyclones and we are very ready to tackle this section of work in the exam. Remember, we looked at all possible questions they may ask you in the exam, from your multiple choice questions to your diagram based questions to a satellite image question to a cross section kind of a question to a just rough sketch kind of a question to a case study based kind of a question to a synoptic weather map kind of a question. Those are basically all possible questions they can ask you. There's nothing else that we left out. So after watching this video, yeah, you'll be able to kill those exams and get a total for this section of work. Remember the tips we gave you on how to approach some of the questions. Use them and ensure that you apply some of the tips we gave you so that you do really well in your examinations. So make sure that you rewatch the video if there are sections that you don't understand. Pause the video when necessary to try and answer the questions themselves before we answer them for you and show you how to approach them. And all the best with your revision again and your final examinations. Look out for the next video, which will be on subtropical anticyclones and all the other subsections that come with it. And this is all for today's session. Thank you very much for joining us in our Pedagogical Science Institute Matric Revision Series for Geography, where we do what we do for the people. Thank you very much. I am Mr. Mbuyisa, by the way, again, and I'm happy to offer the services that we offer. Thank you very much.